Hello guys, welcome to my YouTube channel. Today as part of my assignment, I'm going to explain hash tables and hashing techniques. So let's get started. First, hash tables. Hashing techniques, collision resolution techniques, closed hashing, open hashing, all these topics we are going to discuss today. So first, hashing. Hashing is a popular technique for quickly storing and retrieving the data. The primary reason to use hashing is that it produces optimal results by performing optimal searches. Why do we use hashing method? We use hashing method so that it is easy to find an element. If you keep any element in the hash table, it is very easy to find the element. Whereas in array, it is very difficult. If it is, in some conditions, it is very difficult. So, so hashing is very important. Now, fundamental operations that we can operate on a hash table. We use the hash table operation to create a new hash table. Okay, delete operation. Why do we use this operation? This operation is used to remove a specific key value pair from the hash table. Okay, get operation is used to find a key within a hash table and return the value associated with the key. Put operation is used to add a new key value pair to the hash table. For example, let us consider a hash table. Okay, first let me explain what is a hash table. A hash table is an array. It stores a lot of elements based on its size. For example, if the hash element size is 10, it stores 10 values. Okay, that is called hash table. Now put operation is used to add a new key value pair to the hash table. We can add a new value key value pair to the hash table. So for this put operation is used. Okay, delete a hash table operation. This operation is used to remove the whole hash table. Okay, we can remove the whole hash table by using this delete hash table operation. Okay, now what is hash function? A hash function is a fixed procedure that changes a key into a hash key. This function converts a key into a length restricted value known as a hash value or hash. This is the main important point that we have to remember. What is a hash function? This is a fixed procedure that changes a key into a hash key. This function converts a key into a length restricted value known as a hash value or hash. Now hash table, as I already explained, hash table is an array that stores pointers. Now here they gave an example. If we have a phone number and if we type a phone number on the keypad of our mobile phones, we can observe that the data associated with the phone number, like the person's name and how many times we called that person, how many incoming calls are there, how many outgoing calls are there, all the data will be displayed on the mobile phone. Similarly, hash table is also arranged in such a way. Okay, now characteristics of hash table. It is the effectively calculable, which means that we can easily find the element in the data. Wherever we can observe in the hash table, we can easily find the element. Keys ought to be distributed equally among all the table positions. See, in hash table, in every slot, there is no need that all the elements are filled. Sometimes some elements remain empty. Sorry, some slots remain empty sometimes. Okay, but keys ought to be distributed equally among the all table positions means in hash table elements are distributed symmetrically. It's not like the what? It's not like only on the right side all the elements are filled or only on the left side all the elements are filled. No, the elements are equally distributed. Okay, this also reduces collisions. This also has a low load factor. Number of items in table by the size of the table. Okay, how many items we have in the table divided by the size of the table gives the load factor, and this is low for hash table. This is the characteristic of a hash table. Okay, load factor, low load factor is a characteristic of a hash table. Now what is meant by a collision? Collision occurs when a newly added key corresponds to a hash table slot that is already taken. For example, if we consider hash table of size 10 and let us consider that in sixth position an element named 6 is filled already. Now we have another element named 26, and if we want to place 26 in the same sixth position, it is not possible, right? So if we apply the hash function, we get the same address for 6 and 26. In such cases, this is called as collision. Okay. Now, what are the types of hashing? There are mainly two types of hashing. The first one is open hashing, it is also known as closed addressing, and the second one is closed hashing, it is also known as open addressing. Now, what is meant by division method? Division method is a way of finding an address to the given key. For example, if we have the elements 6 and 26 and we want to store the elements 6 and 26 in a hash table, but we don't know exactly where the address is to store 6 and where the address is to store 26. So for that purpose, we use this method. Now, h of ki is equals to ki modulo m, which means that for the given element, it is divided by the table size and the remainder gives the address of the element to which it is placed in a hash table. See, now we have element 6 and 6 modulo 10 is 6. So the element 6 is placed in the position 6 as we observe here. Okay. For the element 26, 26 modulo 10 is 6 again. See, we cannot place 26 and 6 in a same slot. This is nothing but the collision. Okay. Now we are going to discuss about open hashing. First, we have to learn what is the flow chart of hashing. Okay. Hashing is divided into two types: open hashing and closed hashing. In open hashing, we have only chaining method, and in closed hashing, we have three methods. One is linear probing, other is quadratic probing, and another is double hashing technique. See, now I'm going to explain open hashing method. Okay, now let us consider a group of elements 3, 2, 9, 6, 11, 13, 7, and 12, and we are solving the hash table addresses now, okay, by using open hashing method or chaining method. See, we have the key values as 3, 2, 9, 6, 11, 13, 7, and 12, and we are going to find the locations for all these keys by using the hash function. See, now we are using the division method. What is the division method? We take the values of keys and place into the value of k, and we get some value, and we divide it with 10, and the remainder is given as the address. Now for 3, 2 into 3 plus 3 modulo 10, we get 9, and we place the element 3 in the position 9. And for 2, 2 into 2 plus 3 modulo 10, and we get 7, and we place 2 in the position 7. And for 9, 9 into 2 plus 3 modulo 10, we get 1, and we place 1, and we place 9 in the position 1. And for 6, 2 into 6 plus 3 modulo 10, we get 5, and we place the element 6 in the position 5. And for 11, we are getting the same position, which here we are getting 5. We already know that we cannot store the elements 11 and 6 in a same slot 5. Is it possible? No, it is not possible. So at this condition, what we do is we create a new node. We already learned about linked list. So linked list, now we create a new node and join the node to the location 5. So whenever we access 5, we are going to get 6 and 11 values such that we can easily access the data. And here in 13, the element 13, again we are getting 9. We already know that in ninth position, 3 element is already stored. So again we create a new node and place the element 13 in the data part of the new node, and we attach the new node to the ninth position. Similarly, the elements 7 and 12, we got the same slot as 7. So what we do, we are gonna create a new node for 7 and join to the position 7. And for 12, we are gonna create a new node, and again we are gonna join that to the node which contains 7. And the address of 12 is stored in the address part of node which contains 7. Okay. In this way, we are going to attach the elements in chaining method. Now let us discuss linear probing method. Here we are containing the same example as shown, and we are using the division method and open addressing. Here we have to understand one point. Linear probing method comes under closed hashing. We already know that closed hashing also comes under open addressing, or we can call closed hashing as open addressing also. So now the hash function is 2k plus 3 and the table size is 10. Okay, here they gave a note. If they ask open addressing, we use linear probing by default. Okay, if they ask to solve the problems by using open addressing, we use linear probing method by default. Okay, if they ask specifically for quadratic probing, then we use that. Okay, h of k is equals to 2k plus 3, and the same example. Okay, now we place the key values in a column, in a particular column, and we are searching for the location, and location we solve by using it division method. And of course we got some collisions. These probes I will explain. Okay, after explaining this, search for the locations. Okay, here we got the collision for 11 because the position 5 already the element 6 is stored. Okay, now what we do is to store 11, we got the slot index 5, but it is already occupied, hence we search for the locations near the slot index 5. Here we are gonna search the elements, we are gonna search for the slots which are near 5. See, the 4 is empty, 6 is empty, 7 is empty, 7 is filled. Okay, 6 is empty before filling of 11. Okay, here 11 is already filled, but before filling of 11, the 6 is empty, right? So we are gonna fill 11 in the position 6. Okay, here see, in the above case 6 is free. Here we allocate 11 in the index 6. Here the near the slot index means to search for the locations next to the slot index. Okay, here we should not get confused. The element 6 is stored in the position 5, and to store the element 11, we may search for the positions 4 and 6. No, but we should not search like that. We have to search the positions which are next to the position which collision occurred. Okay, now we should not search the fourth position. We have to search only for the sixth position, and we place 11 in the position 6. Okay, now In similar way, we solve all the collisions. See here 13. We got the same slot index as 9, and we have to search the element which is next to, we have to search the slot which is next to 9. There is no slot after 9. So we again go to the beginning. Okay. At 0th position, there is no element. So we place 13 at the 0th position. Similarly, for the element 7, we got 7, right? We got 7. But at 7th position already 2 is filled, but 8th position is empty. So we place 7. In this way, we will solve and we place the elements in the hash table. Now, order of the elements in the hash table. We write from 0 to 9. What are the elements present? See, at 0th position we have 13 and then 9 and then 12, and in 3rd and 4th positions there are no elements. So we just put blanks at those positions. Okay, and then we place 6, 11, 2, 7 and 3. Okay, and in a technical form, this can be written as insert ki at first free location from u plus I modulo m, where I is 0 to m minus 1. Okay, I will explain this with one example. See, u plus I modulo m, where I is equals to 0 to m minus 1. Here, see, at 6th position, before filling of 11, it was empty. And here, u plus I modulo m. U means this values. Which values? Here, we have got, right, 5 and the address values. Those values plus I. I is equals to 0 to m minus 1. We have to search in such cases. Here I is 0, then we get 5. But at 5, already 6 is filled. So we take I is equals to 1 now. So 5 plus 1 modulo 10 is 6. So at position 6, the element 11 is filled. Okay. This is the technical form of linear probing. See, now I'm going to explain about quadratic probing. Let A is equals to 3, 2, 9, 6, 11, 13, 7 and 12. This is 7. Okay. This is 7 and 12. Now we are going to discuss about quadratic probing, and all the key values are placed in a particular column, and the location we have found, and we have been doing this since division method. Okay, and here we have got collisions again. Of course, we have got collisions 5, 9, 7, 7, and how to solve these collisions using quadratic probing. Now I'm going to discuss. See, the formula is insert ki at first free location from u plus I square modulo m. Okay, where I is equals to 0 to I is equals to m minus 1. See here. From where we have got collisions? We have got collisions from the element 11. So from there we are going to start. Okay. For 11 we have got the position 5. So to change the position, we use the formula u plus I square modulo m. See, here u is 5. Okay. And I is 0. Of course, from 0 to m minus 1 we will search, right? So 5 plus 0 square modulo 10, which is 5. Okay. Here again at 5, element is already filled. So we put the value of I as 1. 5 plus 1 square modulo 10. We got 6 here. At 6, no, nothing is there, no? So we place the element 11 at position 6 for 13. U plus I square modulo m. Okay. 9 plus 0 square modulo 10. Again 9. We get 9. So this is not, okay, this is already filled. So we cannot go for this. And 9 plus 1 square modulo 10. We got 10 modulo 10 0. At the position 0, there is no element stored, right? So we can put 13. Okay. At 0, the position we can put 13. See here, you can observe this. At 0, the position 13 is placed. Now for 12, okay, u plus I square modulo m. 7 plus 0 modulo m, 7. 7 is already filled. Now 7 plus 1 square modulo m, 8 modulo 10, 8. It's already filled. 7 plus 2 square modulo m, 11 modulo 10, 1 is already filled. 7 plus 3 square modulo m, 16 modulo 10, 6. 6 is already filled. Now 7 plus 4 square modulo m, 23 modulo 10, 3. C. Now at third position we can put the element 12. Here we are getting 5 takes to put an element into the hash table. So here how many probes default? Now tell me how many probes. Here we are getting 5 probes. See, that is nothing but probes. Okay, 3 for 3. These all have one probe, and here all after collisions we are going to select the locations. We have got 2, 2, 2, 5 probes. Now go to linear probing. In linear probing, once see how many probings we are getting. For the element 12 we got 6 probes. But whereas by using quadratic probing, for element 12 we have got only 5 probes. That's why we can tell that quadratic probing is better than linear probing. Okay. Now let us discuss double hashing. Okay. Now we have got 3, 2, 9, 6, 11, 13, 7, 12 and use division method and double hashing technique to insert these elements. Here we have two hash functions. The first hashing function is 2k plus 3 and the second hashing function is 3k plus 1. And m is equals to 10. M is nothing but table size, and its table size is 10. Okay. Now insert ki at first place, u plus vi modulo m. I is equals to 0 to m minus 1. Okay. See here we can observe linear probing u plus I modulo m. Quadratic probing u plus I square modulo m. Okay. Here u and v are, here we have told right u plus vi modulo m. Here what are the values of u and v? We get out right default. See here see. U is equals to h1 of k modulo m. V is equals to h2 of k modulo m. Here see. For 3 location u 2 into 3 plus 3 modulo 10 is 9. Okay. And for 2, for these we need not apply all those methods linear probing or quadratic probing or double hashing, because default we are getting the value right, we are getting the location in which the slot is empty right, so we need not solve for these. We have to start the methods where we get collision. Okay, here at 9th location 3 is stored, at 7th location 2 is stored, at first location 9 is stored, and at 5th location 6 is stored. Now the problem we get is from 11. For 11, we are using double hashing here. U is equals to h1 of k percent m or h1 of k modulo m. Okay, we are getting 5, and v is equals to h2 of k modulo m. 3 into, here what is k? Okay, 3 into k plus 1 modulo m is 4. Now u plus vi modulo m is 5 plus 4 into 0 is equals to 5. 5 plus 4 into 1 is equals to 9. Okay, 9 modulo 10. 5 plus 4 into 2 modulo 10. Here we got, what is 5 plus 4 into 2? 8 plus 5, 13, right? 3 modulo 10, 3. So the location we got is 3 for the element 11. Okay. Okay. For 13 we are searching here. U is equals to h1 of k modulo m. h1 of k modulo m. Okay. For 13, what we got the location 9. Okay. U is equals to h1 of k modulo m is equals to 9. V is equals to h2 of k modulo m is equals to 3 into 13 plus 1 modulo 10. Okay. 3 into 13, 39 plus 1 modulo. Okay. 40 modulo 10 is 0. Okay. V is equals to 0 we are getting. U plus vi modulo. Okay. Here v is 0, right? For whatever the values of I you keep, you always get the value 999. Okay. That's why here we cannot insert 13 in this hash table. It is not possible to insert 13 in this hash table. Okay. First, the element 7. U is equals to h1 of k modulo m is equals to 7. B is equals to h2 of k modulo m is equals to 3 into 7 plus 1 modulo 10 is equals to 22. Modulo 10 is equals to 2. Now we have to perform the formula. We have to compute the formula. U plus v into I modulo m. See, U is 7, V is 2. I is changing from 0 to m minus 1. See, first I put I is equals to 0. 7 plus 2 into 0 modulo m, we get 7. This, it is already filled. Again, I put 1, we get 9, it is already filled. I put 2, I got 1, it is already filled. I put 3, I got 3, already filled. I put 4, I've got 5, it is already filled. I put 5, I got 7, and it is already filled. I put 6, I got 9, it is already filled. I put 7 again. Okay, I put 7 here, and I got 1, it is already filled. And I put 8, we got 3, it is already filled. And I put 9. See, I ranges from 0 to m minus 1. We have reached the last point. I is ranging from 0 to m minus 1. Here m is 10, right? And m minus 1 means 10 minus 1, 9. See, 7 plus 2 into 9 modulo m, 25%, 25 modulo 10 is 5. And after putting I values from 0 to 9, still we are not able to find a location. Hence, we can say that we cannot insert 7 in the hash table. No. For the element 12, we are searching the location now. U is equals to h1 of k modulo m is equals to 7. V is equals to h2 of k modulo m is equals to 3 into 12 plus 1 modulo 10 is 7. We have found the u and v values. Now we have to substitute I value, and we have to find the location. See, u is 7 and v is 7. 7 plus 7 into 0 modulo m. 7 plus 7 into 0 modulo 10, which we got 7. 7 is already filled. We cannot put element in 7, right? Okay. Now we go for 7 plus 7 into 1 modulo 10, which is 14 modulo 10, which is 4. Okay, now at 4, no element is present, so we insert 12 at position 4. We can observe at position 4 we inserted 12. Okay, now if they ask the order of elements in the hash table, we can write blank 9, blank 11, 12, 6, blank 2, blank and 3. See, here we can observe it. Blank 9, blank 11, 12, 6, blank 2, blank 3. Okay, I hope you have understood the techniques linear probing, quadratic probing, and double hashing. So please follow my YouTube channel, like, share, and subscribe. Thank you so much. Bye, guys.